Welcome back to This Explainer. Today we're cracking open the biological clock hidden within literally every forest on Earth. You know, timber management relies on exact timing, right? But today we're looking at the strict hard mathematical rules that dictate exactly how a forest grows, peaks, and declines. And, more importantly, how to pinpoint that perfect harvest window. Let's get right into it.
So here's a massive dilemma that keeps resource managers up at night. When is the optimal time to harvest a forest for absolute peak productivity? I mean, you might think the answer is simple, right? Just wait until the trees are as big as possible. But biology is much more complex and mathematically rigorous than that. See, there's a precise, verifiable moment, a biological sweet spot, if you will, when a stand of trees hits its absolute maximum efficiency before it inevitably starts to decline. Cut too early, you leave immense potential on the table. Cut too late? Well, the forest actually starts wasting time and space, biologically speaking. To find that exact moment, we literally have to measure the forest's heartbeat.
Okay, let's dive into this. To solve this harvesting puzzle, we've got to understand the two main competitors in this biological race. First up, we have CAI, or Current Annual Increment. I want you to think of CAI like a biological speedometer. It measures the increase in tree volume or biomass for just one specific isolated year. It's basically asking, how fast is the forest growing right now? Then we have MAI, or Mean Annual Increment. This is your average annual productivity from the exact moment the forest was planted all the way up to its current age. So if CAI is your speedometer, MAI is your overall trip average. Understanding how these two metrics interact, that's the entire key to unlocking forest dynamics.
Now we're going to track a race between these two metrics across the entire lifespan of a forest. Think of this as a chronological biography, broken down into 5 distinct life stages. We start out with stage 1, the young stage, and move through vigorous growth, a maturing decline, a critical intersection point, and finally all the way to stage 5, the old stand stage. As we map out this race through each of these stages, pay close attention to how our speedometer, the CAI, pulls and pushes against our overall average, the MAI.
So, stage 1. This is all about explosive, youthful energy. Think of it as a biological growth spurt, kind of like a teenager eating absolutely everything in the pantry. Let's look at the numbers. Because the trees are young and their growth is rapidly accelerating, the annual volume increase just gets larger every single year. And just like a runner sprinting way faster than their current average split time, this high current growth of 8 violently pulls the overall average of 5 upward. The trees are simply growing faster each year.
Moving right into stage 2, the vigorous growth stage. Our relationship stays the same. CAI is still greater than MAI. But something really fascinating happens right here. The current annual increment, our biological speedometer, reaches its absolute maximum peak first. The trees are packing on volume faster than they ever will again in any single year. It's their absolute prime. However, because the forest is still relatively young, the average productivity, the MAI, well, it hasn't reached its peak yet. It's still aggressively climbing, trying its best to catch up to that massive current growth rate.
But you know, nature always has its limits. Enter stage 3. Things start to slow down. The CAI begins to decline due to some intense environmental pressures. You've got severe competition for sunlight and nutrients between the trees. You have crown closure, which is literally when the leafy canopy overhead grows together and blocks out the sun for all the lower branches. Add in the natural aging process and basic site limitations like soil quality, and the trees start facing severe resistance. Because of all this, our current growth rate, the CAI, drops. But, and here is the vital part, the MAI, the average, might actually still rise for a little bit. It's coasting on the massive momentum of those high-growth early years, so the gap between current and average growth is now rapidly narrowing.
So what does this all mean? Well, the crucial point is this exact mathematical intersection right here in stage 4. CAI equals MAI. This is it, the absolute climax of our biological race. The falling current growth perfectly meets the rising average productivity. The speedometer has dropped down to perfectly match the trip average. Now, why is this specific mathematical intersection so incredibly vital? Because at the exact moment the CAI intersects the MAI, the average productivity reaches its absolute mathematical maximum. The stand literally achieves its maximum average annual production. Boom!
And that intersection unlocks the single most foundational concept in forest management, the biological rotation age. This is the exact age when CAI equals MAI, resulting in the maximum average annual production. It perfectly indicates the optimal time for harvesting. This right here is the finish line of our race. If you harvest the stand right at this age, you guarantee the absolute maximum average yield over the entire lifespan of that forest. Nature has literally handed us the exact mathematical formula for peak efficiency. It's a real game changer. It's the rotation of maximum volume production.
But what happens if you just ignore the math? What if you just let the trees keep growing indefinitely? Well, we enter stage 5, the old stand stage. Now, CAI is less than MAI, and this leads straight to declining stand efficiency. The current yearly growth becomes so incredibly low that it acts like a heavy anchor, actively dragging the overall average productivity down. Yes, the stand is technically still growing. The trees might even look a bit bigger to the naked eye, but biologically speaking, they are growing far, far less efficiently. Keeping the stand longer than the biological rotation age actually reduces your average annual yield. No way around it.
Let's take a step back and see how this all builds across the entire chronological process. This is a perfectly continuous sequence, taking us from youth to overmaturity. We start with rapid growth, where CAI is greater than MAI, pushing the average up. Then, CAI peaks first and begins its inevitable decline due to those environmental pressures we talked about. Next, we hit that golden intersection where CAI equals MAI, locking in our maximum yield. And finally, if left unmanaged, the CAI drops below the MAI, resulting in an overmature, inefficient stand where the average just declines. It is a perfect, predictable biological arc.
Now, if you only remember one single thing from our time today, let it be this: the one-line exam rule, straight from the source material. I'm going to say this slowly so it really sinks in. CAI rises first. Then it intersects the MAI. At that exact moment, MAI becomes maximum, and afterward, CAI remains permanently below MAI. Honestly, memorize this specific sequence and you will permanently understand the mechanical engine that drives forest growth and yield. It is absolutely the golden rule of biological rotation. Thank you for joining me for this explainer.